Good day again to everyone. Before we're going to start, may I encourage to please support this channel by clicking the subscribe button and of course watching this video until the end of the discussion so that you will understand the lesson. Okay, so our focus today is the idea or the concept of normal line. So that when we say normal line, okay, may we just try to define normal line. Okay, now when do we have a normal line? So we can have a normal line, we create a normal line when there is a tangent line. Okay, so when there is a tangent line, so that if we are going to get the normal line is actually the line perpendicular. Okay, it is a line perpendicular to a given tangent line. Now, notice that the normal line is a line perpendicular to a given tangent line. Of course, considering the point of tangency. Okay, so the point of perpendicularity or the point of the intersection is the point of tangency. Okay, so that is where the intersection of the normal line and tangent line. Okay, now how are we going to get the tangent line? Now, considering the tangent line, the slope of the normal line is the negative. Okay, the negative reciprocal of the slope of the tangent line. Okay, so when we say normal line, it is a line that is perpendicular to a given tangent line. Okay, of course, located at the point of tangency or the intersection of the normal line and the tangent line is at the point of tangency. Now, another one is the slope of the normal line is the negative reciprocal of the slope of the tangent line. So that if the tangent line is, shall we say, we have in here, if the tangent line has a slope of m represented by m, then slope of the normal line is represented by what? That is the negative reciprocal of the tangent line. Okay, so meaning this is the idea that we have to remember. Okay, so again, to get the slope of the normal line, we have to consider the slope of the tangent line. So that if the tangent line is represented by m, the slope of the tangent line is represented by m, then the slope of the normal line will also be the negative reciprocal of that m, that is the same as negative 1 over m. So that is the slope of the normal line. So that when we are going to plot these two lines, now it will create a perpendicular lines. Okay, it will create a perpendicular lines. Now, considering that we have a problem in here, it says in here, find the normal line to the parabola f of x is equal to x raised to 2 plus 1 at point of tangency, which is negative 1 and 2. Now, of course, before we're going to solve for the normal line of this one, we have to draw first the parabola. Okay, we have to illustrate the parabola. So our parabola, so that if our parabola is represented by this one, f of x is equal to x raised to 2 plus 1, then notice that the domain are all real number. So that considering my values of x, well, can I make use of all real numbers from positive to negative? I will make use of 2. Okay, so that if my x is 2, my x is 2, x 2 raised to 2 is 4 plus 1, this will be 5. Now, if my x is 1, okay, that is the same as 1 raised to 2 plus 1 will give you, that is the same as 2. So that if my x is 0, 0 raised to 2 is the same as 0 plus 1 is the same as 1. Okay, so if that is negative 1, then negative 1 raised to 2 is positive 1 plus 1, it will give you 2. Now what about if that is negative 2? Negative 2 raised to 2 is positive 4 plus 1 is 5. So that you will notice when we are going to graph this one, it will give you a parabola, a figure that is parabola. So may we graph, so that you will notice if I have this one positive 2, okay, if I have positive 2, you will notice the x will be what? Positive 5. So the point is located in here. Okay, now if I have negative 1, then the value of my y must be positive 2. So we have in here. Okay, ayan. So that if I have 0, then my y would be 1. The same true that when I have negative 1, we have in here negative 1, the value of my y would be positive 2. Okay, positive 2. And if I have negative 2, the value of my y would be positive 5. So meaning the point is located in here. Okay, so that you will notice if we are going to connect the points that we have in here, it will create a figure that is parabola. Now meantime, I have to connect. Okay, let's try to connect. So notice if that is parabola, then this must be the graph. Okay, this must be the graph of the parabola. So we have in here. Okay, so this is the graph of the parabola. Okay, notice that after plotting now the parabola, of course, because we are talking of the normal line, before we're going to have the normal line, we have to look for the slope of the tangent line, or we have to look for the tangent line to a given parabola f of x, which is the same as x raised to 2 plus 1. Now how are we going to get the slope at point, of course, at x is equal to negative 1? Of course, how are we going to get the tangent line? Meaning to say, we have to get the function. So what is our function? Our function in here is parabola is f of x is equal to x raised to 2 plus 1. And so that when we are going to get the derivative of this one, that is the slope of the parabola. So what is the derivative of f prime of x? The derivative is the same as we have in here. That is the same as we make use of the shortcut, okay, power rule. That is 2, okay, multiplied by of course the x raised to 2 minus 1, okay, shortcut. We're going to make use of the shortcut method. So what is the derivative of the constant? We have said that the derivative of the constant is always 0. And so meaning to say, what is the slope or what is the derivative of our parabola? That is, we have in here f prime of x will give you now that is the same as 2x. So that is 2 minus 1, that is the same as 1, or that is the same as our parabola now, or the slope or the derivative of our parabola is 2x. And so we can now say that the slope, okay, the slope of our tangent line is the same as 2x. What about if we are going to consider the point of tangency? Our point of tangency is negative 1 and 2. So meaning our point of tangency is we have negative 1 and 2. Now so that you will notice we replace now the x in here, so that 2 multiplied by what is your x? Your x is actually negative 1, okay? Negative 1, and so the slope we have in here is negative 2. So that is the slope of the tangent line, okay? So that is the slope of the tangent line. Now notice that of course, because we have already the slope, we have the slope of the tangent line, okay? We have to get the equation of the tangent line, okay? So before we're going to plot, let's try to get the equation of the tangent line. Now equation of the tangent line, we have to consider again our point slope formula. What is that point slope formula? That is y minus y1 is equal to m multiplied by the quantity x minus x1, okay? So of course y1 in here and then x1 pertains to the point of tangency, okay? Point of tangency. So again, our slope in here is negative 2. So how do we consider that one? Let's try to have y minus, what is y? What is y1? That is 2. That is 2. And of course, what is the m? That is negative, okay? Negative 2. Negative 2. And then of course, multiplied by x. What is our x sub 1? Our x sub 1 is negative, okay? Negative 1, okay? So that is our x sub 1. Now considering that one, let's try to simplify. So y now is equal to y minus 2. It will give you now that is the same as negative 2x, and then that is positive 1 multiplied by negative, so negative 2, okay? Now notice that when we are going to get the value of or the equation, that is the same as saying y is negative 2x, that is the same as negative 2, that is to be transposed, that is positive 2. So our y now would be negative 2x, so that after knowing now the equation of the tangent line, now we might as well do this one, okay? Of course, before you're going to establish that this is the equation of the tangent line, now you might as well recheck if you have a proper computation, so that if this is true, that this is the equation of the tangent line, then we are now ready to have the tangent line. Okay, notice that the point of tangency is in here. This is the point of tangency. Let's try to have point of tangency is actually this one, or in our table, our point of tangency is, we have in here point of tangency. Okay, so notice the location is, we have in here. So from the point of tangency, if our slope is negative, meaning to say the denominator of our slope is 1, okay? So change of the slope is actually the change of y over the change of x, so that with that, our slope now is negative 2, and our change of y is negative 2, and the change of x is 1. Okay, now how are we going to graph from that? Notice that we go down 2 units from the point of tangency. 2 units. Okay, so we have in here 1, so 1, 2. Okay, so 1, 2. Now and then, of course, change the change of x positive from this one going in here. So meaning to say, our point, our tangent line is, of course, passing also the point of origin. Okay, so this is already now the point of tangency. Okay, notice that after having now the point of tangency, that's the time we're going to compute now. Okay, we can now compute the slope of the normal line. Okay, so meaning when we have this one as the slope of the tangent line, then we can have the slope of the normal line. So what is the slope of the normal line? The slope of the normal line, okay, let's have this one, slope of normal line, or shall we say m sub nl, okay, is actually the reciprocal of the tangent line. What is the reciprocal? That is the same as negative reciprocal of the slope of the tangent line. So how is that? So the slope now of the normal line is equal to the negative 1. Okay, what is the slope of the tangent line? The slope of the tangent line is negative 2. So that if that is negative 2, meaning to say the slope now of the normal line is the same as positive 1/2. Okay, positive 1/2. So this is already the slope of the normal line. Now, because we have the slope of the normal line and point of tangency, we can now solve, or we can now draw the normal line. Okay, we can locate by having this one, so that of course our reference is point of tangency. So again, notice that if we are to have this one in here is actually the value of change of y, and 2 in here is the value of change of x. We will count from where? From the point of tangency. So that if we have this one, the point of tangency, we will count upward, because that is positive, upward 1 unit. Most probably it is located in here. And then 2 units go to your right. 1 and 2. Okay? So 1, 1 and 2. Change of y, which is positive 1, and change of x, which is positive 2. So we have in here the expected point. Now after having the expected point, we can now draw that expected point to the point of tangency, and you will notice I will make use of blue. You will notice that if the red, my red in here is the tangent line, okay? Tangent line. The blue, this line now is the normal line. Okay, normal line. So that you will notice they are perpendicular to the tangent line, and normal line is or are perpendicular to each other, meaning to say they create an angle which measures 90 degrees. Okay, they create an angle which measures 90 degrees. So that notice again that if I have this normal line, the slope, okay, the slope is actually positive 1/2. Now what about the tangent line? What is the slope? The slope is negative 2. Now so that when we define the normal line, it is a line perpendicular to a given tangent line or to a tangent line, which is this one. Okay, we're at the point of tangency. Now another one in here, the slope of the normal line is the negative reciprocal of the slope of the tangent line, so that if the slope of the tangent line is positive, its opposite is if the slope of the tangent line is negative 2, then the slope of the normal line must be positive reciprocal of negative 2, which is the same as 1/2. Okay, which is the same as 1/2. Now you might be thinking of the equation of the normal line. Okay, the name of the normal line, the same, that when we are going to have the equation of the normal line, then we use the same form, that is y minus y sub 1 is equal to m multiplied by x minus x sub 1. Okay, so that if we are going to have now the equation of the normal line, y, which is, what is our y? Point of tangency. Our always reference is point of tangency. So this is the point of tangency. That is, our y is positive 2. And of course, what is the slope of the normal line? 1/2. Okay, 1/2. And of course, that is x minus, what is x? Negative 1. Okay, negative 1. Now having said that one, we can now compute. So that is the same as y is equal to that is the same as y minus 2 is equal to 1/2. 1/2, that is the same as x plus 1. Okay, so that if you try to compute, that is the same as 2y minus that is the same as 4. Okay, it will give you x plus 1. So that you have now in here, that is the same as y 2 2y, I should say 2y is equal to x. So x plus 1 plus 4. So it will give you now 2y, which is the same as x plus 5. And what is your y? That is the same as what now? Y now is the same as x plus 5 over 2. So this is the equation of the tangent line. Okay, so for the equation of the normal line, so this one is tangent line. Okay, so the equation of our tangent line, we can say that the equation of our tangent line is y is equal to negative 2x. Now, what about our normal line? The equation of our normal line also is y is equal to x plus 5 over 2. So, yan. So that is the normal line. Okay, I hope you understand how to graph the normal line and how to solve for the normal line. Again, to solve for the normal line, first we have to look for the derivative of the given parabola or given curve. Then after that one, identify now the slope of the tangent line to point of tangency. After having now the slope of the tangent line with reference to our point of tangency, that's the time now we're going to get the slope of the normal line. So we have said that the slope of the normal line is the negative reciprocal of the tangent line. So that after having now the tangent line, we can now draw the tangent line with reference again to our point of tangency and to the computed slope of the normal line, which is 1/2. Okay, applying now the counting using the counting the change of y and counting the change of x, so we can now solve for the we can now have the expected point, wherein when we connect this expected point to the point of tangency, it will create now a perpendicular line, so that if they are perpendicular lines, perpendicular to with respect to tangent line, then that must be now the normal line. And of course, when we say perpendicular lines, they create 90-degree angle. Okay, they create 90-degree angle. So I hope you understand how we took the normal line. Thank you and more power.